Okay, so we want to write complex numbers, and we want to write them in trigonometric form. Okay, so we're going to take trigonometry and put it together with complex numbers that we saw back in Chapter 3. All right? And if you remember, a complex number would be something of the nature A plus BI, where A is what we call the real part, and BI is what we call the imaginary part. Do you remember that? Niza says, no, I do not remember that. Then let's just refresh your memory, Niza. We would have, say, 2 minus I would be one imaginary number, and we had the conjugate, which was 2 plus I. And those were solutions that often came from the quadratic formula. 4 plus or minus the square root of, say, negative 4 over 2. And when you take square root of a negative, you know, you get that imaginary portion. So, you know, that's the kind of stuff that we get that from. Well, when we graph numbers, and just to relate this to your previous knowledge, if you want to plot x equals 5, if you want to graph x equals 5, we draw a number line, and you write number 4, number 5, number 6, and you put a circle, right? So plotting a number on a number line is one of the most basic things that we can do, right? We're going to do the most basic thing that you can do with complex numbers, which is plot them. Now, you don't plot them on a number line because this is the real number line axis. Within complex numbers, we have a real axis, and we have an imaginary axis. That makes up what we call the complex plane. Because we have 2 lines, it does create a plane for us. And so now we can plot them. I'm going to draw my graph out 5 units. 1, 2, 3, 4, 5. I had my in-laws over yesterday. Had them over for chicken dinner. We had barbecued chicken legs, cornbread muffins, sweet corn, twice baked potatoes. Oh, it was so good, so good, so good. Okay, in order to graph z sub 1, z sub 1 is equal to 2 plus 4i. I want to graph 2 plus 4i. Very simple. Watch how I do it. I move over on the real axis 2 units, and on the imaginary axis, I move it up 4 units. I plotted z sub 1. Z sub 1 is over 2 units on the real axis and up 4 units on the imaginary axis. So just like, don't think of this as plotting like XY, you guys. This is not XY. XY is, you know, you plug in X, you get Y. They're related in that way. This is like plotting, the way that you want to think about this is like plotting the number 5 for real numbers. That's what we're doing. We're plotting numbers. Okay? All right, our second one, negative 1, negative 5i. We back 1 and down 5, so this would be z sub 2. Any questions about plotting imaginary, or I'm sorry, complex numbers? Seem pretty straightforward so far? Then let's just change it up a little bit. It says do z1 plus z2, z sub 1 plus z sub 2. So I'm going to take z1, which is 2 plus 4i, and I'm going to add that to negative 1 minus 5i. How do I do that? The real numbers together, which gives us 1, and the imaginary numbers together, which gives us negative I. So 1 and negative I places us there, which is z sub 1 plus z sub 2. So tonight I'm going to ask you to practice this in homework, that you would practice plotting these. And this will be your first type of question on the test. These would be questions that I would assume that everybody's going to get, because you're all more than capable of doing this. Now, this is negative z sub I. I'm sorry, I hit the I key as opposed to the 1 key. It should be negative z sub 1. So negative z sub 1 would be equal to, how will I calculate that? Multiply everything through by negative 1. So 2 plus 4i times negative 1 will give me negative 2 minus 4i. See, you can take this home tonight and show your parents. And, you know, they'll say, what are you doing? And you'll say, well, I'm plotting complex numbers on the real and imaginary axes. And they will blow a brain gasket. Yes. Negative 2. Back 2 on the real axis. Negative 4. Down 4 on the imaginary axis. Negative 2. Negative 4. That does not answer your question. Okay. Well, let's try the next one together. 1/2 z sub 1. So if I want to plot 1/2 z sub 1, I will take 1/2 of z sub 1, which is 2 plus 4i. Niza, when I take 1/2 of 2 plus 4i, what do I get? And how do I graph that? Yup, over 1, up 2. That'll be 1/2 z sub 1. Good. What's that? One plus 2i plus 4 minus 6i. Well, if you got 3, then you're still going to combine them. The 4 is going to go with the 1 and give you 5. Has to be either real or imaginary. It has to be one or the other, and so we just come up with 2 parts. Good questions. Any other questions on problem 1? Leave them. Modulus. Modulus is a new word. I don't even know if I'm pronouncing that correctly. I think I'm modulus, okay? Modulus is this, the absolute value. Yeah. No. Sorry. I don't remember. Modulus. It's with a U. Modulus. Thank you, Nathan Ragulin. The absolute value of z. Now, just think on this for a second, you guys. Don't write this down, but think with me very, very intently on this. If I ask you the absolute value of negative 5, what do you tell me? You tell me 5. How did you get that? You make it positive, right? Well, then what about the absolute value of 1 minus 3i? Remember that absolute value is not talking about just making something positive. Absolute value is the distance. Yep. From the origin. Well, on a number line, in the real number line, it's very easy to just say, well, negative 5 is obviously 5 units away from the origin. But look at this example. Let's say you want to focus on z sub 1 right up here. and you want to know how far is z sub 1 from the origin. What is that distance? What would you do? Distance formula, otherwise known as the Pythagorean theorem. Look, we have this a value, this real value that we would square. And then we have this b value, which we would square. And we would take the square root of that. So, in other words, the modulus is simply the absolute value of z, which is equal to the square root of a squared plus b squared. Nope. Can't do that. Can't take a root of parts. Okay. So, it says find the modulus of z1 and z2. Z1 is equal to 2 plus 4i. So the modulus is the absolute value of z sub 1. And the way that we calculate that is we take the square root of, what is a? A is 2. What is b? 4. Not 4i, just 4. So we take a and we square it, plus, whoop, I guess I should actually write the value. Two squared plus 4 squared. Nope. I is just like a label telling us it's on the imaginary axis. We don't actually use that in the calculation. It's 4 units in the imaginary direction. So we get the square root of 4 plus 16, which is 8, and the square root of 8 is 2 square roots of 2. What am I doing? I don't know. The square root of 4 plus 16, which is the square root of 20, which is 2 square roots of 5. Sorry about that. I don't know what happened. I must have been thinking about the next problem. The I is gone because the I does not tell us distance. The I tells us that it's in the imaginary, it's towards the imaginary axis. By our label. We define one to be real, we define one to be imaginary. Graph what? No, we don't have to, but that's what it is. 2 square roots of 5. It's that length right there. That length is 2 square roots of 5. So that's the absolute value of it. Okay, we do a similar thing for z sub 2. Yep, z sub 2 is equal to, what, negative 1 minus 5i. So the modulus is the absolute value of z sub 2, which is the square root of negative 1 squared plus negative 5 squared, which is the square root of 1 plus 25, which is the square root of 26. And that's it. Nope. So all we've done so far is we've plotted complex numbers. Can you do that? Second thing is we found the absolute value of a complex number by use of the Pythagorean theorem. Can you do that? All right, let's get some more difficult material then. So this is where we will end our lesson with example 3. We need to now talk about the trigonometric form of complex numbers. So we want to take a complex number and write it in a form that involves trig. And this is extremely useful to us. It's hard to tell you why right now, but it is. So we're going to plot this. We're going to call this z, which is equal to a plus bi. As you can see, it makes a triangle with an angle of theta. What's that? Right here? Yes. So, very good. What do we call this length right here? This bottom length. How far over is this thing? It's A. And how tall is this? It's B. We are going to call this length right here, okay? This length right here, the distance that the complex number is away from the origin, that's its modulus, right? Which is the absolute value of z, which we could say is the same thing as a radius. A radius is always positive. Okay, now if I want to convert this, so what I want to do is I just want to rewrite this stuff. I want to take this number right here, a plus b, I want to rewrite it to involve trigonometry. Because if you write things in trig, it's going to make it easier for us in the long run, and you'll see why. So here's what I'm going to write. Cosine of theta is equal to something, and sine of theta is equal to something. What is cosine of theta equal to? Adjacent over hypotenuse, which is a over r. I'm going to solve for a. How do I solve for a? R times the cosine of theta is equal to a. Sine of theta, what is sine of theta equal to? Opposite over hypotenuse, or b over r. How do you solve for b? R times the sine of theta is equal to b. So you can see what I've done right now. I've solved for a, I've solved for b. And what I could do is I could take that r cosine of theta, I'm going to put this right in for a. I'm going to take this r sine of theta, and I'm going to put that in for b. And so you can see that you get a new expression, namely that z is equal to, instead of a, I have r cosine of theta, plus, instead of b, I have r sine of theta, and then I have my imaginary piece right there. Is everybody okay with what I wrote? Do you see where it came from? What can I factor out of both of those? An r. So z is equal to r times the cosine of theta plus I times the sine of theta. I just moved the I to the front. And that is your trig form of an imaginary or a complex number. So if we want to write a trig form of a complex number, we need two things. We need to know r. Any idea how we find r? R is the same, very good, by example 2. R is the same as the absolute value of z, which is the square root of a squared plus b squared. And I need to find theta. Well, you could write a number of things to satisfy theta. We'll use this one. We'll say tangent of theta is going to be equal to b divided by a. So, in order to write complex numbers in trig form that looks like that, I have to use those two pieces. That is the number one piece of understanding that you need to get out of today and that you will have to have in order to do your homework, which you have to start tonight. Otherwise, you will forget, and I will become angry. So, we do these 3 examples, and that's where we'll be today. Write the following complex numbers in trigonometric form, okay? I just want you to think through this really quick, okay? Look at this. If we were to look at these as 2 axes and label them as quadrants, 2 plus 2i, which quadrant would I be in? 1. So over 2 and up 2, I'd be right here, okay? So my angle should be between what 2 degrees? 0 and 90, okay? Let's just understand that, all right? Now, I need to come up with r, and r is equal to the square root of a squared plus b squared. What's a squared plus b squared? 8, which is equal to 2 square roots of 2. So I've got r. That wasn't that bad, was it? Now I need theta. Well, I know that the tangent of theta is equal to 2 over 2, or 1. Where is tangent equal to 1? Tangent is positive in the first quadrant and in the third quadrant. It is equal to 1 at 45 degrees or at 225 degrees. Which one do I want? 45. Well, Taylor asks a very good question. How do we know what value tangent would give us? You got 2 ways. Your calculator. Oh, always use tangent. Let's always use tangent. Tangent of theta is b over a. So you have that unit circle sheet I gave you from earlier in the year, right? I think that would really help you because we don't want to write these in degrees either. We want to write them in radians. What is 45 degrees in radians? Pi over 4. Very good. So, yep. So now I'm going to take this pi over 4, and this r is 2 square roots of 2, and I'm going to write the trig form of this complex number. 2 plus 2i is the same thing as 2 square roots of 2 times the cosine of pi over 4 plus the sine. I times the sine of pi over 4. Those are the same. In fact, you guys, if you calculated the cosine of pi over 4, it is the square root of 2 over 2. If you would calculate this stuff and then distribute the 2 square roots of 2 through, you would come up with exactly that 2 plus 2i. I mean, because cosine of pi over 4, like I said, is square root of 2 over 2. And the sine of pi over 4 is square root of 2 over 2. So as you distribute, you would come up with this exact same thing. They are the same, 100%. Why would we do that? Some people say, well, it looks more confusing. We can work with this a lot more easily than we can work with this. Trust me. Okay, let's try the next 2. We've got time. The last one's really easy. Okay, for number 2, which quadrant am I in? For the second one here. I'm in the second quadrant, okay? I'm back 3 and up 3 square roots of 3, something up there, right? Sorry. Forgot to put the I there when I wrote the problem. Sammy should hit Ryan. That way he'll thank you later. Negative 3 plus 3 square roots of 3i. We need to figure out 2 things. We need to figure out r. How do we figure out r? Square root of negative 3 quantity squared plus 3 square roots of 3 quantity squared. What's negative 3 squared? 9. What's 3 square roots of 3 squared? 27. What's 9 plus 27? 36. What's square root of 36? 6. If you take 3 squared to 3 squared, you square the 3 to get 9, right? And square root of 3 squared is 3. 9 times 3 is 27. There we got it. So r is equal to 6. Well, now I have to figure out theta. I know that tangent of theta is equal to 3 square root of 3 over negative 3, or negative square root of 3. Now, this is the value of knowing your trigonometry. I know the answer right now is 2 pi over 3, because after you get so ingrained to using that unit circle, hopefully you remember that. If you don't, here's what you have to do. You probably found it in degrees first, then convert it backwards. You guys go to second, let's make sure I'm working in degrees. Go second tangent inverse, negative second square root of 3, and you get negative 60 degrees. Okay? Well, that is not quite as helpful as we would hope, but we can at least get started. Where is tangent negative? The second quadrant and the fourth quadrant. And you just came up with a negative 60. Okay, so that's a 60-degree reference angle. So I'll have a 60-degree reference angle up there. Am I talking about the second quadrant or the fourth quadrant? Why? Because of what we decided right here. We are working in the second quadrant. So therefore, what is my angle? 120. And what is that in radians? 2 pi over 3. Theta equals 120 degrees, which is 2 pi divided by 3. So that sheet I gave you at the beginning of the semester, the unit circle basics, that might be one you want to bring back into the mix. What's that? I could try to run one off for you. So we want to write the trig form. It would be our radius, which is 6, times the cosine of our angle, plus I times the sine of our angle. And that is the trig form of that complex number. We ran right up against the hour last time. Will be the same thing here. Okay, last example. Can I erase? Negative 2i. Which quadrant? Sits right on the imaginary axis. Sits right on the imaginary axis. What's its distance from the origin? 2. What is the angle of rotation? 270, which is 3 pi over 2. So we already know those pieces. If you were to continue to go through the motions, you could say r is equal to the square root of a, which is 0 squared, plus b, which is negative 2 squared. What are you going to get? Square root of 4, which is 2. And then theta is, to find theta, we use tangent of theta is equal to b, negative 2, divided by a. A is 0. Negative 2 divided by 0 is undefined. Where is tangent undefined? 90 degrees or 270 degrees. Which one do you want? 270, which is 3 pi over 2. So that means in order to write this in trig form, I have 2 times the cosine of 3 pi over 2 plus I sine of 3 pi over 2. So, can you graph complex numbers? Can you find the absolute value? Can you transform them into trig form? That's the more questionable one. Here's your assignment. You do need to practice this. The first few problems are very, very, very basic. Just graphing and finding absolute value. 23 through 21 is practicing transforming them. Please, please, please work on them tonight. You will be much better off if you give this some needed attention. Goodbye, YouTube Nation.